So let's treat the last aspect of substitution, mechanism of substitution reaction, which is what? Nucleophilic substitution reaction mechanism. So, nucleophilic substitution reaction mechanism. This nucleophilic substitution reaction mechanism can be achieved when nucleophile initiates the substitution reaction. And the common example of this reaction is hydrolysis of a key halide by sodium hydroxide. Is what? Call it what? Hydrolysis of what? A key halide by sodium hydroxide. Look at it. Now, a key halide is known as what? RX. Hydrolysis of sodium hydroxide. Take this OH out of it. So the product, it will give us what? A key hydroxide alkanol plus X minus. The product here, this X, we can also call it what? That living. We call it what? Living group. Is leaving this alkene and OH enter. This one, it will give us what? Alkanol. Whenever you hydrolyze alkyl halide and sodium hydroxide, the product given is what? Is alkanol. And the kind of what alkyl halide you use will determine the kind of alkanol we have. And the nucleophilic substitution reaction mechanism can be divided into two parts. Can be divided into what? Into two parts. What is the first one? The first one is known as what? SN1 reaction. The second one is what? SN2 reaction. Please. So this nucleophilic substitution reaction, it can exist in two forms. SN1 reaction and SN2 reaction. Let me start from SN1 reaction. That's what? SN1 reaction. SN1 reaction mechanism. SN1 reaction mechanism is very easy. This SN1 reaction mechanism stands for unimolecular. You know what? Unimolecular nucleophilic. Philic substitution reaction. The full meaning for SN1 is what? Is unimolecular substitution what? Reaction. And this SN1 reaction, in this SN1, the rate of nucleophilic substitution reaction depend the what? Depend only on the concentration of the substrate. Concentration of what? Of the substrate. What is the substrate here? Don't forget. Here, this key halide here is what? Substrate. This OH here is what? Reagent. Correction of what? Of substrates. What is the substrate? A key halide. So, if the of the what of the substrates abi good, let me write it out here. You will now have the rate of reaction. Therefore, rate of reaction is proportional to what? Substrates. Substrates. And the substrate is a key what? A key halide. So, and the power of rate here is this. You can now have rate of reaction here equal to what? K, the substrate, of the substrate exponential what? 1. Therefore, the SN1 mechanism of reaction, SN1 of the action is the the reaction is first order. The reaction is what? Is first what? First order, and it consists of two steps. Consists of what? Of two steps. So these are the basic necessary facts on SN1 what? Reaction. Let me give you one example on the SN1 reaction, and is what? Is mechanism. Now, example on SN1 reaction, let me say example what? Reaction. Example, so consider the hydrolysis of two methyl propane. Consider, I don't know what, 2-methyl propane in the presence of what? Sodium hydroxide. Let us look at this reaction, class. What will happen here? 2-methyl propane. This will be the symbol. This will be the equation. 2-methyl propane CH3, comma, CH3, yes, Br, CH3, 2-methyl, yes, propane, CH3. If this compound reacts with what? Sodium hydroxide as reagent, and what happens to the what? To the product form. The product form will be having what? CH3, C, CH3, comma, OH, CH3, good, plus sodium bromide. This OH we have here, it replaces bromine here. That's why we call it what? Substitution reaction. The OH replaces bromine. You can see OH here. This bromine replaces what? The OH here. Yes. If you are now asked that what is the mechanism of this reaction? What? Mechanism of the reaction. The mechanism of reaction is comprised of two steps. The first one is what? Step what? Step 1. Formation of carbon ion. Formation of what? Carbonium, sorry, ion. Formation of what? Carbonium ion, a carbon with positive what? Charge. If you remember, in electrophilic substitution reaction, in step 1, formation of what? Of electrophile we need. It will now react with what? The substrate, which is benzene. But here, the step 1 is formation of what? Of carbon what? Carbon ion. So if you are looking for the formation of carbon ion here, what will happen? You know that is what? The compound given is this. Let me draw it out. We have CH3 in this form. We have HA. Then we have Br here. We have CH3 in this form. We have another CH3 here. This is what? 2-methyl, 2-bromo, 2-methyl propane. Yes, this structure. This is what? The structure. Abi now, you have what? The formation of carbon what? Carbon ion. That is what happened here. This bond will now shift towards to bromine. Homolytic what? Homolytic fission. If the bond shifts to bromine, this carbon will call in what? In this form, CH3, CH3 plus bromine. And the bromine we have here, this one will become a what? A positive. Bromine will become a negative. The compound that you have there is what we call what? Carbonium ion. That's what first thing we need in what? In step 1. What happened next? In this step 1, don't forget 2. The sodium hydroxide will also what? Ionize here. The sodium hydroxide will also what? Ionize here. Hydroxide will ionize to have sodium what? Plus OH minus. So this is sodium plus, this is OH what? Minus. Then at step 2, what happened? In step 2, here, step what? Step 2. The sodium, yes, the OH, O what? OH will serve as what? Nucleophile. Yes, we attack the what? The carbonium ion. This OH attack the what? Carbonium ion. If this OH want to attack the carbonium ion, we are going to have this. Where is carbonium ion? This is it. We have carbonium ion in this form. CH3, CH3, CH3. Good. And we have what? our OH here. This is carbonium ion is positive, OH negative. I've said it several times that the carbonium ion is what they are unstable. This OH is also what unstable. As a result of that, the OH will find means to what? To react himself to carbonium what? Ion. Will find means to react himself to what? To carbonium ion, because the two of them are what? Are unstable. As a result of that, this OH will what? We attack the carbonium ion here. When it attack the carbonium ion, the product is now be what? CH3, 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 then OH. And this is what the product form. This is what the product what form here. And the bromine that is what? At last, this bromine that we have here and the sodium that we have here, you now have what? Sodium ion plus Br. Let me remove this. They will give you what? Sodium bromide. So this is what? The end of the reaction mechanism for SN1. The SN1 is known as what? Unimolecular nucleophilic reaction. It is first orders of what? Of reaction. The rate depends on correction of what? Of substrate alone. And it consists of what? Of two steps. It consists of what? Of two steps. That is all about SN1. Let's make up the board and explain the SN2, which is known as what? Bimolecular nucleophilic reaction. Yeah. So let us look at SN2. S what? SN2 reaction. If you are talking of SN2 reaction, the SN2 stand for, or the meaning stand for bimolecular substitution reaction. Bimolecular substitution what? Reaction. And this SN2 of the things, the rate, the what? The rate of reaction, or the rate of what? Of reaction, which is what? Let me write it where I wrote that. The rate of nucleophilic substitution reaction depends on concentration of substrates and reagents. And what? Reagents. That is, the rate of reaction is proportional to the count of what? Substrate, straight, spell is not correct here, and what? Reagent. This is the substrate, acrylate. OH is what? Is reagent. So from here, you can now have what? the rate of reaction, I've explained this under rate of chemical reaction. Yes, in first semester, you now have K should be what? The rate here, substrate, which is alkyl and sodium hydroxide, which is what? Reagent. Power here 1, power here 2. Therefore, the order of the reaction is second order. So we can say what? The order of reaction is second what? Order. Or the reaction is second order of what? Of reaction. Let's look at what? One example on these two. See what? Consider, look at the example of this, the hydrolysis of methyl bromide. Of what? Methyl bromide with hydrolysis of bromide by sodium hydroxide. If you look at what methyl bromide by sodium hydroxide, this is what? CH3 Br from sodium hydroxide. This is substitution reaction. We have CH3 OH plus sodium bromide. So this is what? The reaction. You are now asked, explain the mechanism. Good. Lest I forget here, the mechanism here is one step. One what? One step. So if I want to explain the mechanism of this reaction here, start from this is what? CH3. No, let me shift it to the back. Shift it to the back. From here. The mechanism of the reaction. If we have what? C. Good. I have C Br H CH3 H. We have it in this form. The surprise, this sodium hydroxide here, the sodium hydroxide is this. This is sodium hydroxide. It will ionize to have sodium plus OH minus. Plus minus. See, this OH we have here, this is it. The OH we have here, let me put it here. This OH that's ionized with sodium hydroxide, this is it here. So the OH now what? Attack the what? This carbon from the what? From the back. It will attack the what? The carbon from the what? From the back. And it will now give us what? This. Look at the carbon. This is the carbon. This. No. This is my carbon. And we have what? First hydrogen, the second hydrogen, and this hydrogen. Don't forget that is what? The SOH is attached to this from the where? From the back. Abi? And this what? Bromine, the leaving group, we have it in what? In the front here. This is what? Bromine, the leaving group. So, be the what? The transaction between the what? OH and the what? OB. This is also partial negative. This is also partial negative. And this transaction, we are call it what? Is a transition state. We call it what? State. Transition state. This is what? Transition stage. So at this transition stage, this will now give us what? Like this. And then we are, no, let me change it to blue. I'm using blue marker for the arrow. Yes. So it will now lead us to the what? This bromine is leaving group. So the OH we what? We replace it. We have H, HA, and at this side we have what? OH plus the BR. So the BR will now later react with what? With sodium hydroxide there. So that is what? The SN2. So the next aspect that I'm going to explain now is what? We are done with what? Substitution reaction mechanism. Once again, substitution reaction mechanism is a reaction in which one of the atom of the molecule or functional group of the molecule is replaced by another atom from another molecule. That's substitution reaction. And it can be grouped into three. When substitution reaction is initiated by what? Free radical, we call it free radical substitution reaction. If it's initiated by what? Electrophile, what? Electrophilic substitution reaction. By nucleophile, nucleophilic substitution reaction. And we have SN1 and SN2 reaction. So that is all about the mechanism of nucleophilic substitution reaction. The next one that we are going to move towards is elimination substitution reaction mechanism.